This conference will now be recorded.
Success is the sum of small efforts, repeated day in and day out. Good evening, everyone. Thanks for joining us. I am Jalan from the Department of ECE, and I will be hosting today's webinar. I welcome you all for this wonderful webinar on satellite communication insights. Prayer is aligning ourselves with the purpose of God. Now I call upon Ms. Sharon and Ms. Neha to lead us in prayer. Over to you, Ms. Sharon.
Today's Bible verse is taken from 1 Corinthians chapter 12 verse 8. For to one is given through the Spirit the utterance of wisdom, and to another the utterance of knowledge according to the same Spirit. This is the word of God. Thanks be to God.
Lord's Prayer. Our Father who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses as we forgive those who trespass against us. And lead us not into temptation, but deliver us from the evil. Amen.
Thank you, Ms. Neha and Ms. Sharon. Small cheer and great welcome makes merry feast. Now I call upon Ms. Hridaya to welcome everyone for this webinar. Over to you, Hridaya.
Thank you, Jerlin. Good evening to everyone gathered here. I hope everyone is safe and doing good. Thank you, Almighty. It's my pleasure to extend a cheerful welcome to you all, and on behalf of Loyola Institute of Technology, our management, administrator, principal, vice principal, cum HOD of ECE department, we wholeheartedly welcome all the participants for this webinar. On behalf of the department, we, the coordinators, welcome our resource person of today's session, Mr. D. Gururaj, Assistant Professor, Rajalakshmi Engineering College, Chennai. It's my pleasure to extend a cheerful welcome to you, sir. Your presence makes us very happy. I'm sure we will be enriched by this webinar on satellite communication insights. Thank you, sir, for accepting our invitation even in this pandemic situation. We welcome you wholeheartedly for the webinar. In this context, I congratulate all the coordinators of this webinar, faculty members of ECE department, and professional friends to make this happen. Dear participants, once again, I welcome you for this wonderful technical day. Thank you. Over to you, Jerlin.
Thank you for the hearty welcome, Ms. Hridaya. Now it's time to introduce our speaker, Mr. D. Gururaj, sir. Ms. Afrin Fatima will give a brief introduction about the speaker. Over to you, Ms. Afrin.
Thank you, Jerlin. A very warm welcome to one and all gathered here. I am Afrin Fatima from the Department of ECE, and it gives me an immense pleasure to introduce our resource person, Mr. D. Gururaj, Assistant Professor, Department of ECE, Rajalakshmi Engineering College, Chennai. His areas of expertise are wireless communication, mobile and satellite communication, and digital signal processing. He pursued his UG in Electronics and Communication Engineering from Hindustan College of Engineering, Chennai in the year of 2010 and PG in Communication System from Hindustan University, Chennai in the year of 2012. With his passion towards teaching, he guided and mentored multiple student communities towards a bright future in the past 9 years of his teaching experience. He has published 9 publications in reputed international journal and has presented in various international conferences. He owns 2 patents and has applied for 3 funded projects, which is now under consideration. Now, he is with us to make this session more interesting and knowledgeable. We gladly welcome you, sir. Once again, thanks for joining with us, sir. Over to you, Jalan.
Thank you, Ms. Afrin. Before handing the session to our speaker, dear participants, if you have any queries during the course of this webinar, kindly post it in the chat box. All your questions will be answered at the end of the session. Now, our speaker will take over the session. Over to you, sir.
Thank you. Good evening to one and all. Can you hear me?
Yeah, you are audible, sir. Good evening, sir.
Good evening. Thank you. Thank you. First of all, I thank the management of Loyola Institute of Technology for inviting me for a wonderful session of satellite communication insights. First of all, I thank upon the management for inviting me, and I thank upon Principal Dr. Shrita Anand ma'am and Vice Principal ma'am and HOD of HOD for Department of ECE, Dr. Nalini Joseph ma'am, and organizers Sharmi ma'am, and then those who have been helping the students. Thanks for inviting me. So let's start the session. So what is mean by a satellite? So instead of having a one-way communication, let's have an interactive session. Anyone can open up your and let me know the answers. So what are the things you have heard about the term satellite? Why there is a specific paper that need to be studied satellite separately? How does it impact in our day-to-day life? That's what we're going to see here. So what are the things you have heard about satellites? Can anyone open up your mic and answer it? Let's have an interactive session.
I request the students to unmute your mic and talk, please.
Can you hear me? Hello.
Yes, sir, you're
So
audible,
I've
sir.
given you a picture. Okay.
Talk louder.
Yeah, ma'am. So I show you a
Clara,
picture. Anyway, you people can at least listen. Uh, that's the important thing we need to understand here. Satellite, remember, a satellite is a moving body, or you can call it a celestial body that helps in communicating between your Earth as well as your outer space. So these are the general things that has been happening. That has been happening here. These are the general things that is been a satellite is been doing here. So the satellite, it will be, you have seen about it. It's like a bird. It is having a center body and wings that has been spread out in the space. And so what are things it has been doing here? It has been communicating with your Earth station, and it has been doing lot of other things. It's been going around here. So what are the obstacles it has been facing in its day-to-day activities? It has lot of it has undergo a lot of electromagnetic radiations around it. It needs to transmit the signal without any loss to the time between the transmitter as well as your receiver. So this what are things that has been basic things that a satellite requires. So for communicating satellites, we require two major things: your satellite system and your uh, Earth station. So these are the two major things that's useful for communicating between your satellite station. These two things, what are the parameters we need to undergo? That's what we'll be seeing in the coming topics. So my ultimate aim of a satellite is to provide communication between your Earth station as well as your satellite. That's it. This is my concept of for designing a satellite. So how I'm going to do these things? What are the factors that has been involved in communicating between your satellites? That's the most important part. These two, if you this is first we need to always whatever problem statement you're defining, first we need to define the problem statement correctly. For satellite communication, the two things is very important. How I'm going to communicate between them, what are the factors that is been involved, what are the devices I'm going to use for communicating between these two things, that is your Earth station and your satellites. These are the three major factors that require for communicating between your satellite as well as your Earth station. So if we define the problem statement correctly, from that we can able to understand very easily. So first we'll be studying about what are the plans that has been used for communicating between your satellite and your earth station. So the satellite we know that it is in Latin word that means an attendant. It's attendant is giving you a communication which is constantly covering around the attending a master or the big man, giving the information or transmitting the communication every other things. So how it has been done with the help of your X station. So how it has been done, how it has been hello, hello.
Yes, sir, you're audible,
Yes,
sir.
sir, you're audible, sir.
Suddenly said audio connection has been lost. So okay. So for transmitting and receiving, what are the parameters I'm going to choose? So the parameter I'm going to choose is your frequency. For transmitting frequency, I need a important parameter is your power. How I'm going to manage the power between your station and your satellite. So for giving the names for connecting communicating between your station and your satellite, what are the parameters I need to check? I'm going to give the name as uplink as well as your downlink. So the uplink here mentioned is for your transmitting from your earth station towards your satellite, and communicating back from satellite towards the earth station is called as your downlink. So how for this I need some set of frequencies to be added. As I mentioned earlier, the satellite must undergo a electromagnetic radiation. Instead of living in electromagnetic radiation, we are already living in electromagnetic rain. So to avoid interferences, to avoid attenuation, we need to work on it. So for that, we need to give a separate band of frequencies towards your satellite. So what is the separate band of frequencies? So for uplink, I should have because for mobile phones we are using frequency. For TV, we are using frequency. For radar communication, we are using frequency. For navigation purpose, we are using different frequencies. Likewise, for different applications, we have different frequencies. Likewise, for different applications, we have different set of frequencies. So it controls different bands of frequencies. So for satellite, starting phase of satellite in 1945, they have started with L band. After that, the ITU, that is your International Telecommunication Union, has been designed to perform. They have been providing uh, frequencies for various applications. So for like this various application, the satellite comes with your two bands of operation, that is C band and KU band. So the C band operation is in the range of 4 to 8 gigahertz. So remember, in satellite, your uplink frequency will be always higher when comparing with your downlink. So for in the range, the C band, the uplink frequency is 6 gigahertz range, and the downlink frequency is your 4 gigahertz range. Why? So that's always the question asking here. So you might be asking either in a MCQ questions, or it can be used in your part A questions. Why your uplink frequency has been higher when compared with your downlink frequency? So the uplink frequency, because we cannot go to we can if there is any, if I want to send more power, if I want to increase the power, I cannot take a rocket and go to satellite and increase the power over it. Instead, I can increase the power for transmitting a signal in the earth station. So the uplink power is very high. Similarly, while coming downlink, there will be always distortion in the signal happens due to your rain, winds, many other things. So the downlink frequency, because we know that higher frequencies are more sensitive to your signal. So the downlink frequency is very high. more susceptible towards your lot of noises. So the downlink frequency is lower when comparing with your link. Remember, we are satellite, we are operating in gigahertz, whereas in mobile communication, it has been operating in megahertz. Understand the differences. Mobile communication, we are using in megahertz. A satellite, we are operating in gigahertz. Many people will be getting confused with the range. We know the value, but we forgot the range. Gigahertz means 10 power 9. So here we'll be calling them as your transmitter and your receiver. Iridium has been particularly meant for capturing the unwanted EMF noises. We'll be using to avoid the disturbances happening in it. Okay. So this is how the data has been transmitted, the data processing, and the data has been transmitted over this. I taken from the ccturtle.org how this data has been. So the data transmitted is happening in the navigation purposes, and the data processing is being done here, and is being sent towards your data processing center. So this is how the satellite is being monitored each and every second. How it has been how it has been moving, or whether it has been sending the data, whether it has been sending the data. Everything has been done here. Latestly, China has sent a rover towards some Mars to collect the data what is happening in a Mars. India has already sent in 2011 and 2014. Sorry, 2014 MOM, Mars Orbital Mission has been already sent. We have been working on for past 7 years. And US has been sending the lot of rovers from 2007 to research what is happening in the Mars. Now, as I said earlier, the frequency allocation is most important part in your satellite things. So the C-band uplink is 6, downlink is 4, K-band is 14, 12. Remaining things we have been used for some particular basic particular purposes that has been defined in different set of levels. So the first satellite has been launched in by Russia. It has been launched in outer space is your Sputnik. It has been designed and developed and manufactured in Russia, and it has been launched in 1957. So India's first rocket launch, the first satellite launch is satellite launch via rocket is been done in 1975. The name of the satellite is your Orbital. So this most of the questions will be asking when you're getting into an ISRO. First satellite which has been launched, first satellite which has been successfully launched. There have been lot of failure based upon lot of failures only. We have achieved very huge successes in your satellite communication level. So the frequency bands of allocation. So for L band, we'll be using for your mobile satellite services. S band is used for NASA deep space research and nuclear thing. C band is for the fixed satellite services. X band is used for your FSS and military terrestrial earth exploration and meteorological services. K band is used for your broadcast satellite services. So in our home we're using DT. In many people are using DTH, right? So the DTH has been working in the KU band of operation. So predominantly using a C band as well as your KU band. Remember the values for KU band and C band, because that will be as many of two mark part A questions or in the MCQ questions, whichever side right has been happening already. Next. So the frequency allocation has been done with the help of your ITU, because the frequency sharing is most important, because there has been a lot of conflict will happen when there is happen during your frequency sharing problems. So it is been based upon the needs and the application. The frequency is being allocated based upon international agreements. So for the frequency allocation, we need to go for a separate topic and just giving you the gist. So it has been done with the help of your proper sensitized antenna receiver to the earth station, so that it will be able to pick only what need frequency. Because in our phone we will be having a frequency receiver, the same thing will happen in frequency receiver. That we'll be having a lot of frequencies around the antenna. In that it should be more sensitive. Which frequency I'm going to capture, how I'm going to handle the situation. So these are the things that has been happening in FCC. That is a USA. For each and every country, they have the different levels of communication commission that has been happening. So for international travel, the common form has been made International Telecommunication Union in 1932. That has been consist of 150 members nations. Based upon the studies they have been given, but this particular frequency has been used for your particular things. Next. So what are the, I listed some applications of your satellite. That is your global communication. For example, if the satellite particularly meant for we can able to operate in your remote areas. So if you look, for example, if you take a mobile tower, if you want to communicate using a mobile phone, I cannot go each and every 5 kilometers. I cannot go and deploy the uh, towers so that the communication to make the communication happen, I can go and deploy the towers in each and every 5 to 10 kilometers continuously because if the number of users will be very low. In order to get into the remote areas, particularly for a very deep down villages, sea and air, I cannot go for a mobile communication. So for that, I can need to communicate. I can have the very accuracy based communication. So I can trust this as satellite communication. So it is in land, ocean, air, everything is going to happen in the global telecommunication. So as well as I can able to transmit in a very better way, in a very quicker way, I can go for broadcasting. So that everybody can able to get the information very quickly. So it is in the multimedia communications and the DTH, DTU, DBS. That is the DTH is a direct to home. It has been happening with the help of the satellite communication. DBS is your direct broadcast services. So it has been used for your business TVs. Everything has been using in your broadcasting services. And the navigational purposes. Navigation purposes we are using GPS. So we look at the mobile phone. We have been using your mobile phone for a long time to search the location. So the location-based services has been helped with the help of your GPS system. GPS system has been operating in the based upon your satellite. We'll be setting GPS system in coming minutes. And then, so one of the important application of the satellite is your remote sensing. That is, it can go to the places where the communications cannot be held. It can able to capture the particular. For example, I want to go on research a particular forest or research a particular ocean. I cannot keep the communication in each and every part. So instead, the particular area I can make a road map. From then I can go insights what is actually happening over there. So as for Earth's observation, how the climatic is been changing, how the ocean waves has been moving, everything I can able to done with the help of remote sensing. With the help of remote sensing only, I can able to calculate the weather conditions, whether there is a possibility of storm, whether the possibility of famine, whether the possibility of flood, whether the possibility of icebergs breaking. So everything I can able to monitor with the help of your remote sensing applications in using your satellite device. And emergency communication like disasters, mobile communication services, that is your satellite mobile phones. Satellite mobile phones are very costly, and to use to use a particular satellite communication, I need to work on the larger thing. So instead, many people will be using your conventional type mobile communications. Next, corporate communications are virtual private area networks, reset technology, and particularly for military applications, so that they don't get hacked away. They don't get the information from one person to the other person. So that's an important application of your one of the few important applications of your satellite. These are the diagrams of your satellite things has been happening. And important thing is your now Starlink. It is in a Starlink is an project that has been designed, developed by your Tesla Corporation. It has been done with Mr. Elon Musk. He has been giving you a Starlink. Starlink is a project that has been providing internet to everybody. So he is providing internet to everybody to all over the world. He is having the constellation of satellites. What is the constellation of satellites? Constellation of satellites is here. We can have a number of satellites that has been arranged in a proper direction. We are already working in microwave only. Microwave in that range only actually working on the satellites. So the Starlink is an important we can call them revolution in your internet industry, where they will be providing you the internet using your satellites. So that Tesla Corporation, it has been providing the internet. They're trying to provide internet all over the world by deploying the satellite all over the world. There is a conflict that has been happening between OneWeb as well as your Tesla Corporation, sorry, particularly for the Starlink project, because there is a possibility of clashing both the satellites. That makes a lot of cost. We know that deploying a satellite takes huge amount of money when comparing with deploying a towers. So these are the different services of satellite systems: fixed satellite services, broadcasting satellite services, mobile satellite services, navigation satellite services, meteorological satellite services. This is how the process has been happening here. Yeah. So this is a point-to-point link has been happening between your one earth station to also another earth station via satellite, and then point to multi-point will be having multiple receivers. Will be having only one transmitter by multiple receivers. It's like your DTH is a good example of a broadcast link. Point-to-point link is a good example for the military communication, where they can able to communicate between the two borders, between your west and east border. How I'm going to communicate between east and west border, the point-to-point link. Whereas the broadcast link is particularly meant for a DTH. The transmitter will be sending a thing, and the particular frequency, if you change the channel, automatically it will be changing towards the things. Next. So I have a satellite. Where I'm going to place the satellite? How I'm going to place the satellite? So I need a space. For example, if you're buying a bike, you definitely require a parking space to keep your vehicle, or a bike, or a car, or a lorry, bus, whatever things, we need a parking space. Likewise, how I'm going to place a satellite? So for placing a satellite, there comes a concept called as your orbit. So what is meant by an orbit? An orbit is a well-defined geometry in which the satellite is revolving around the Earth. It takes a defined organized space, or you can call it defined organized journey at a particular latitude and longitudinal positions, such a way that it has been revolving around the Earth for their required applications. So you have four types of orbits. So first is your Leo orbit, that is your low Earth orbit. Low Earth, you can call them low Earth equatorial orbit. Second is your medium Earth orbits or Molinier orbits. Third is your geostationary orbit, and fourth is your polar orbit, and you have Huffman transfer orbit. That will be coming. That will be studying in your coming topics. I'll explain these five orbits. So the lower orbits are the orbits that is been ranged in near 160-kilometer range to 1,600-kilometer range satellites which has been placed nearer to the Earth is called as your lower orbits. From 1,600 kilometers to from 10,000 kilometers to 20,000 kilometers is called as medium Earth orbits, and then for your 36,000. Can you hear me, ma'am? Can someone hear me? Can you at least post in the
Yes,
chat
sir.
box?
Yes, sir. We
Yes,
hear
sir.
you, sir.
Increase your volume, sir, just a bit. Sometimes it breaks.
There is some server problem issues. Can you hear now, ma'am?
Yes, sir. Yes, sir.
Yeah, okay. Sorry for the interruption. The server issue. Because we are using the conventional internet. If you satellite internet, we don't have the server kind of issues. There is issue with satellite, then only can able to have it here. Thank you. Just a joke. So for low Earth orbits, there is in the range from 160 to 1,600. For 10,000 to 10,000 will be in your medium Earth orbits. For geostationary orbit, it's important orbit in a satellite communication that has been placed in your nearly approximately 36,000 kilometers. Accurately, it is 33,786 kilometers. So, if the satellite is placed in 36,000 kilometer, it can able to monitor the Earth with the same speed. So, why it is called as geostationary means the satellite will be revolving the Earth. The satellite will be revolving the Earth speed. So, only it is called as a geostationary orbit. And we are studying about polar orbit. So the polar orbit is a concept where it is being the satellite is being particularly meant for having the sending information between your north and south poles. So well, it's called as your polar orbits. And Molini orbit is called as the Huffman transfer orbit. So for transferring the geostationary, I cannot take a rocket that can travel up to 36,000 kilometers and face the orbit, and the rocket will get dismantled. Instead, what will be doing here is the rocket will be moving to a particular limit. So after the particular limit, there will be an motor called apogee kick motor. We have two orbital elements, that is apogee and perigee. So the nearest point to the Earth is called as perigee. The longest point is called as apogee. So the rocket will be place a satellite in a particular. For example, I'm launching a geostationary satellite. The rocket will be placing the satellite in the perigee point. That is the closest point here. So after that, we keep revolving in the satellite. It will be revolving either in an elliptical path or circular path. Depends upon the application. It will keep on varying. So predominantly, it will be working on a elliptical path. So what will happen here? What will actually happen here is the apogee kick motor. Once for every revolution, it will be keep on increasing. It will be forming a very bigger circle. It will be forming a very bigger radius from the perigee point. So for each revolution, keep on it will be forming a very bigger circle, and finally it will be reaching to your geostationary point. So until reaching it, the power it will be used in your satellite. So that will be setting, the subsystem will be setting in the coming minutes. This is your axis. So it has been happening here. So look at here. How it has been satellite has been placed here. So about 1,000 kilometers called as low Earth orbits. About 10,000 kilometers called as medium Earth orbits. And high elliptical path is called as your, we'll be calling them as your geostationary orbits. So these are the three classes of your satellites. So the satellite orbit will be varying depends upon your altitude, inclination, and your orbital period. So the orbit is a path of a satellite that follows a revolve around the Earth, or you can call it a geometry where the satellite is in spaces. So the applications in the LEO orbits are remote sensing satellites, altimeter satellites, and etc. And the medium Earth orbit will be setting about your altitude between 5,000 to 20,000 kilometers, as I said earlier, 10,000 to 20,000 or 5,000 to 10,000, depends upon the. So the medium Earth orbit is particularly meant for your GPS purpose. That is your global positioning system. The geostationary orbit is a 24 hours period that is used for 20. We keep on working for 24 hours for the communication purposes. This is your comparison chart between your geo, MEO, and your LEO. So this is your simple how the satellite has been launched. Earth surface, and we'll be having LEO. We have 5,000 to 50,000, 10,000 to 20,000. We'll be having MEO. Upper Valence is called 30,786 kilometers. Will be placing your geo orbits. So the advantages of geo orbits is we know the problem with you, there won't be any frequency changes. Will be fixed. The frequency will be fixed in it. Then tracking the satellite is very simplified because it will be rotating in your Earth's speed. So, for example, if it's, for example 12 o'clock, it will be placed in particular latitude, means the next to 12 hours where the satellite is where the Earth is in moving, the same satellite will be also placed in the same place where the Earth is the coverage area. For example, it will be covering a particular latitude and longitude. The same latitude and longitude will be covering in the also. The tracking is making very simple. Will be having high coverage area because when you look at closer, for example, if you take a lens, if you keep, I'll tell you. So if you keep a lens nearer towards your paper, the focusing space will be very less. When you keep on increasing the lens along the paper, it tries to cover the whole area. The same thing when you're keeping the satellite in the longest part, I can able to coverage the long things. So that part will be calling them as your how there is a proper communication between your Earth station and your satellite. That concept is called as your look angle determination. How the look angle determination is been uh, how the look angle determination is been defined for a satellite and the Earth station. Remember, the look angles is a concept where the antenna footprint. Antenna footprint means antenna footprint means it is a coverage of an antenna. How much area it has been covered, how the signal is being received. So that's what if you look at your normal dishes and the satellite dishes will be very bigger. It will be in the range of 24 to 36 meter in diameter. So they can able to capture all the signal that has been sent by the satellite, and with the sensitive antenna, it will be taking out only the which is actually needed. So that is for antenna look angle determination. So if it is east west, there's a lot of concepts that will having behind your satellites. So the disadvantage of geostationary, there has been weak signal traveling between your 35,000 kilometers. Remember, for example, throwing a ball within the ground, it will be, for example, simply throwing means it will be going a small distance. When you're giving a high, almost. So the polar regions are very sorry for the issue with the audio server. So signal sending has been delayed substantial near geo-orbit. So advantages and disadvantages. Similarly, for LEO and MEO, they'll be having they have the own advantages and disadvantages. So next, orbital location. So the location of a geostationary satellite is referred as an orbital location. International satellites are normally measured in terms of longitudinal degree east from the pre-meridian of 0 degree. The geographic area of Earth's surface over the satellite can transmit or receive from its called as your satellite footprint. I said earlier. So these are some persons who have been working on the concepts of satellite space objects, particularly for the orbit, how it has been happening. It has been started with Copernicus. From his student Kepler has been started learning from the Kepler. From Copernicus idea, the Kepler has been keep working on it and then find out it has been found in the elliptical path, and a lot of universal law of gravitation has been made. From every other parts, the satellite is being made with certain three different rules that has been defined by Kepler. And the important three rules. The first is here: the orbital path of a planet takes from the shape of an ellipse, with the sun located at the one of its focal point. This is the basic concept of your how satellite has been revolving between the sun and a focus point. And this second thing is, so there's an always confusion with the second law. A line from the sun to the planet sweeps of equal area and equal intervals of time. For example, I'm taking area A and area B. So the area A and area B is same because for covering the area A, it has been taking the time T1 and T2. And for covering the area B, it is taking the time T3 and T4. So the area, if you look at normally, if you look at the area covered will be very huge for area B and area A. But actually, the same area it has been covered for the nearest point as well as your farthest point. So the time T1, T2 that mentions your satellite traveling between your time T1 and T2. So from the point you can, if you draw a geometry, the both area will be remaining the same. That's what they call as apogee and perigee points. Because in apogee it will be moving in the slowest way, whereas in perigee it will be moving in the fastest way because of your large gravitational pull. So the third law, it has been talking about your area covered as well as your time period. So the ratio of the square of a planet's orbital period is a cube of the mean distance from the sun is constant. We studied about these things, Kepler's law. These things you already studied. This the importance of apogee and perigee and ascending node, descending node, retrograde, true anomaly, mean anomaly, everything. The important thing is your angle of inclination. Uh, because it plays a major role. It plays a major role in the defining of antenna look angle determination. These things you have already studied. I just want to show you the diagrams. Next, the important thing is your orbital perturbations. The So orbital perturbations will be always or will be always having the some concept, because we know that we are whatever defined is will be defined as a Earth is a perfect sphere. Remember, Earth is not a perfect sphere; it's an oblate sphere. I'll repeat again: it's an oblate sphere. What does it mean? Is the Earth is bulged in equator and flattened in the poles. The structure is, if you look at the Earth, it will be flattened in the poles and bulged in equator. That's what we are giving you the polar orbits to cover the particular range. You cannot able to cover because it is a total flat in polar regions and bulger in your equatorial part. That is east west is bulger, and the north south polar regions is your flatter parts. So here we'll be having due to this orbital, but due to this there will be a regression of nodes. So as I said earlier, as an equatorial bulge causes a component of gravity vector acting on a satellite to slightly out of the orbit plane. Well, if a satellite is been revolving around the Earth, there will be always a gravitational pull towards your satellite. You can have a question: how the satellite is been space how the satellite is being placed in orbit? What are the two forces that have been acting on a satellite? Remember, the two forces that help the satellite to work on it is your centrifugal force and centripetal force. Centrifugal force that helps you to keep the things out of the gravitational pull and push. The centripetal force helps to keep the satellite revolving around the orbit. These are the two forces that helps in this. These are the two basic forces. So what you have studied in your schooling levels, the same thing we are applying for the satellite also. So centrifugal force it has been pulling the satellite in. The centrifuge will be pushing the satellite out. So to balance these two things, if you balance the centrifugal force, it will be moving around the Earth. So apart from this, because of an equatorial bulge, there will be a lot of gravitational pull in your satellite. So it will be instead of for example, if you draw a circle, if you take a compass and draw a circle and putting satellite means it will be actually for ideal theoretical purpose, satellite should always keep on in the particular line alone. It should not come in, it should not go out. So there is this. Actually, the satellite is been moving out of the Earth with it is moving with degree by degree. It is moving within very minute degree. So for regression of nodes, it will be for per year. It has been moving in the range of 1 degree per year. That caused very huge things that have been happening here. How am I going to resolve this issue? So it is being resolved with the help of your it has been resolved with the help of your approach kick motor. Whenever there is a change in the orientation of a satellite, automatically approach kick motor is switched on. That is, it will be switching back to its original orbit position. Hey, சும்மா வந்துட்டு இருக்காத. Go to your original places immediately. With the help of the automatically, once it in place, it will keep on revolving around over there. These are users. These are the conditions for a geostationary satellite. So next is the subsatellite point. So these are the things that have been parameters for study for the antenna look angle determination. The point on the Earth that lies directly below the satellite is called as your subsatellite position. So the location of satellite is given by the longitude and latitude of the subsatellite point. The subsatellite point of GEOS lies on an equator. If you stand here, if a fan is if you are standing if the fan is straight to the head, it is called as a subsatellite point. It is called as sub point. So for same thing, if standing on the earth station, it is standing directly towards the satellite is called as a subsatellite point. We know the radius of the Earth is 6,378 kilometers. So one of the another thing is your angle of tilt angle as well as limits of visibility. So limits of visibility means, for example, we have a vision. So for example, if you're looking at straightly, you can have 180-degree shift. That is, I can able to see what is happening around me in a 180-degree point. Same thing for satellite, there is a range. So the satellite, the limits of visibility is ranging from plus or minus 81.3 degree. The plus or minus means it may having left and the right. It is taking in terms of your graph. It is 81.3 degree. It is called also limits of visibility. It can able to the angle can be made is minus 81.3 to plus 81.3 degree. So if you take 180 means from 0 to it will take 162 something, and the range it will be staying from the range from 0 to 162, or it will plus or minus 81.3 degree. So the angle of tilt is called as a declination. It is due to happening due to your magnetic declination of the compass readings. In a magnetic declination, a magnetic pull and push, the angle is changes. So angle of tilt mostly in the range for the 0.5 maximum 5 degree declination. The angle of tilt will be available. Can you help me to share my screen? We can go to the next design parameter. Hello, can you hear me, ma'am?
It says you are the presenter now, sir. You can continue, sir.
Sorry, ma'am. Yeah, thank you. So we are moving to the second part, your subsystem and your link design. So in the subsystem, what are the major subsystems we have studied here is this as the first one is about your subsystems. So in that we have almost 6 types of subsystems in your satellite. Before getting in design, we just have to just over the subsystems and what are the operations has been happening there in a lighter note. The satellite subsystems are the important parameters that help the satellite to move around the component that is being placed in your satellite. The first and foremost subsystem is your power subsystem. So how satellite is been getting power? So as I said earlier, the satellite is like a bird, will be having a central body and wings. So the wings they have been deployed with your array of solar powers. They having the high solar plates that has been available in your satellite. So in practically till 2018, the efficiency of the solar panel has been ranges between 21% to 24%. Whereas the satellite they have been trying to demon this. Yeah, functioning understood. So the for power subsystems, it has been helped done with it has been done with the help of your solar panel that has been present in the layers of your satellite. So what if what will happen during your sun transit outage? What will happen during your eclipse time? So during eclipse time, the satellite power supply will be got infected for 5 to 10 minutes. During the those 5 to 10 minutes, there will be an internal battery available in your satellite that will be automatically switched on during eclipse time. During the sun transit outage, that will be range for up to 72 minutes. Sun track means the sun will be acting as a very disturbance for your particular satellite. So for during that time, how the power system has been operating. So the batteries that has been present in your satellite that helps in automatically switch on and provide the battery makes the satellite work in a normal condition. So during the extreme condition, when solar panel does not work, the batteries get drained. So what will happen during these extreme conditions? There is a nuclear power generator that is been present in each and every satellite that is being manufactured after post 2007 and 8. Post 2007 and 8, there will be a nuclear generator that has been present in a satellite. During your extreme conditions where it is going to drain your solar power, energy that is being supplied from the solar power, and then your batteries is getting drained, automatically then it will be switched on. Remember, it has been not used in the normal situations. Remember, it has been not used in a normal situation during the extreme conditions where your both of energies or your power substance has been getting collapsed. So this is an importance of the power subsystems. So the batteries has been made with your nickel cadmium batteries. Predominantly using nickel cadmium batteries to transmit and receive your net station. Next, attitude and orbital control subsystem is an important subsystem for design and development of the satellite. So the attitude orbital, it has been the attitude tells about the concept of your orientation in space, how the satellite is being oriented in the space. We have two types of attitude control, that is active attitude control and passive attitude control. Active attitude control means it is correcting if there is any orientation in the signal that is receiving towards the earth station, it automatically switch towards your another part. If there is an so what will happen? What will actually happen? What will happen here? There will be an automatic orientation again back towards original position. A passive orientation is, as I said earlier, using your Apogi kick motor or Periki kick motor. It helps the system to work on it. Next, thermal control subsystem. We know that thermal control subsystem is an we know that when the device is been exhibiting some signal, there will be always heat energy is being generated. To control those heat energy, there will be some blankets that have been available called as thermal blankets, thermal shields that helpful for the control of your thermal and keep control the heat that has been generated in your satellite and try to keep in the cooling manner. Next, TTC. TTC is your telemetry tracking command subsystem. The telemetry tracking command subsystem is an important subsystem where it will be having all the information of your satellite. It will be having all the information of your satellite, where the satellite has been going, what the satellite has been doing, what are the works that need to be done. So you'll be having a command subsystem present in the station, in the station control room, whereas the telemetry that collects information from the satellite. If there is any issue, then there will be having a lot of sensors that are available in the satellite, power sensors, altitude sensors, thermal sensors, and transponder sensors. Will be having many types of sensors been available in your satellites. So it will be collecting all the information, and it will be sending information to the command subsystem. If there is any resolving issue, you automatically send the command to the particular sensor and correct it. And tracking is already mentioned here. While the satellite has been moving each and every point, will be monitoring each and every latitude and longitude. If there isn't sudden any changes in the orientation or any change in the orbital path of the satellite, automatically reports to your command system. Next, antenna subsystem. The antenna subsystems we already shared here. That should be having more sensitized thing to capture only the what frequency actually I need. Next, so next is your communication subsystem. So for communication subsystems, we'll be having transponders. So the transponders will be having a lot of things, and the transponder will be having many devices. It's like we'll be having amplifier. We'll be having amplifier because water signals will be transmitting in a very low level. I need to transfer for the longest distance. So for that, I need to have a high power amplifier. So a communication subsystems will be having high power amplifier. We'll be having multiplexer, demultiplexer, modulator and demodulator because I need to transmit as well as receive. I didn't change. I'm just talking with this. I'm just telling you that just over here and be moving to the link design. So the communication subsystems will be having your high power transmitters. I'll be having a multiplexer, demultiplexer, everything that's been available here, and I'll be having a connector. I'll be having revolution, everything we can have in a communicating subsystem that helps in communicating between the subsystems. Now we move on towards your link. Now we'll be moving towards your link design. So now, as I said earlier, during the starting of this webinar, I have been discussing about the concept of how I need to communicate between your earth station and satellite. This is my simple problem statement. How I'm going to things. So I have studied how first I have studied about what is satellite, how the satellite is being placed, what are the subsystems that have been available, how the signal is being transmitted and received, how the communication is been happening over things. Now, what are the factors that affecting the signal transmission and your reception? What are the things? So that's called as your link budget calculation. That is, I'm connecting your earth station, satellite, earth station, or transmitter, satellite, receiver, whatever it may be. It can be a receiver. Receiver can be your TV, mobile phone, any other devices. Receiver. Ultimate name is transmitter, satellite, receiver. How the link is been happening? What are the parameter factors that has been affecting this particular link? That's what we're going to see here, because we are working in the outer space. In inner space itself, we having a lot of noise disturbances that has been happening here. As the outer space, we cannot predict what kind of situation has been happening in outer space. So we need to calculate everything what is happening around the outer space. So the first thing is your propagation factors, because the satellite it is moving in a wireless propagation. It's called as a free space propagation. So in that first we'll be studying about your atmospheric losses. So atmospheric losses is called a radio wave transmission in a satellite system, atmospheric absorption, atmospheric attenuation, traveling wave, ionospheric distribution. So the radio propagation atmospheric absorption, because for example, we know the signal we are transmitting it is an electric and magnetic field. It's a combination of there is an EMF wave. Yeah, it is electric and magnetic field. It is being absorbed with many factors. Remember, it is absorbed with many factors. So in that one of the factor is your atmospheric absorption. It will be having gases that are able to absorb the radio waves. So there will be two absorption peaks absorbed. That is 22.3 gigahertz from the So I need because for water vapor it is 22.3 gigahertz for resonance absorption and 60 gigahertz resonance for your oxygen absorption. Next, atmospheric attenuation. So atmospheric attenuation, there is an important parameter of rain. The rain plays a key role. So the rain is a main atmospheric attenuation. Here is nice. So the why, because is we know that the raindrop that is been falling in it will be like spherical. So for this we need to understand about the concept called polarization. So what is the polarization? So the way in which the signal has been received is called as polarization. So what are the polarizations we have studied? We have studied about linear polarization. We have seen about circular polarization. We have heard about elliptical polarization. The polarization is how it is been happening here. So for linear polarization, we have two types of. So for linear polarization, we have two types of reception. horizontal and vertical. For circular polarizations, we'll be having the radius based polarization. In elliptical polarization based upon the semi-major axis, major axis will be working on it. Now, so what will happen during your rainfall? We know that the high frequencies are more susceptible to the rain. Particularly, your KU band is more susceptible towards your rain attenuation. That is because the atmospheric atmosphere has been having more rain. First point. Second point is, so what will happen during your signal has been received? So if a raindrop is falling upon the particular frequency, the this time, so the polarization, the rain falls upon the particular signal. What will happen here is automatically the circular polarization will be changing its angle to an elliptical polarization. The elliptical polarization will be having dismantled totally, and it will be flattening the signals. So the circular remote begins flattening signals, and signals are getting largely attenuated. So the rain causes main cause of an atmospheric attenuation. The total attenuation. Can you hear me? For each and every second, it is saying that the audio has been problem. Where is it?
Yes, sir, we can hear you, sir.
Can you hear me, ma'am? Students, can you hear me?
Yes, sir. Yes, sir. You are able to hear. You are audible, sir.
Thank you, thank you. So the rain causes a major continuation because of because the reason is it changes the polarization. For if it is vertical, it will change to horizontal. If it is circular, it changes to elliptical. It will be if it is left hand circular, right hand circular will be happening here. If it is left hand, it will be automatically changing switching here. So the receiver gets confused which data should be recovered. So due to a lot of fluctuations. So the further we have AH is equal to alpha into L. Alpha is your specific attenuation based upon the range. L is in path length when you study in wireless communication. And then ionospheric disturbances like scintillations and polarization rotation. So what is the signal polarization? It's a property of an electromagnetic wave that describes the direction of the transverse electric field. That's more than enough. Which way I'm going to receive the polarization? Linear, circular, and your elliptical. So like exactly 90 degrees out of phase and every other things. So this is how the vertical polarization and horizontal polarization has been happening between your satellite and your earth station. Next, how the rain depolarize your signal. This is a vector equation of these things. So we know that raindrops, some will be not, perfectly spherical, some may not be perfectly spherical. So when it is crossing the polarized wave, one component of the wave will encounter less water, other will be component and the other component. So there will be difference in attenuation and the phase shift experienced by each of the electrical field component, resulting in the depolarization of your wave. So this is how the polarization vector related to the major and minor. Yeah. So how the rain depolarization happen? As I said earlier, the rain will be flattening the signals, or it will be disturb the one side of the polarization. That will be forming in your signal depolarization of your due to your rain. Yeah. So next is your cross polarization concept. So one of the important, one of the cross-polation discrimination concept is interference in the orthogonal polation is to provide isolation between the signals. Yeah, I'll come to the point. TDM concept. First, we'll complete the link design. This is how the actual how the polarization has been happening. Depolarization has been happening between your signal, your transmitter, and your receiver. So here the ionosphere can cause the electric vector of signals passing through the rotate away from their original polarization direction, hence causing the signal depolarization. The sun is an we know the sun is an can be having as a noise distribution contribution to the C by N ratio, because we always remember we'll be calculating your C by carrier to noise ratio. To absorb the effects of the atmospheric constant cause an increase in sky noise that absorbed by the receiver. Next, atmospheric absorption. So you'll be having rain as more attenuation. The rain absorption has more attenuation than fog, than atmospheric absorption. It is very little when comparing with your rain and your fog absorption. Is there any issue with the audio? No? Only some audio connection is really fault. Okay. So the link power budget calculations. So remember, for calculating the uplink and downlink, the important parameter will be, as I said earlier, the important parameter is your received power. The received power is always in your dB watts. It is being calculated with your EARP, gain receiver antenna gain, and then we'll be subtracting the losses. So losses, what are the losses will be happening? Will be forming it just in coming minutes. So ERP is equal isotopic radiated power. That is your transmitted power and your gain of a transmitter antenna. Link budget parameters. So the link budget parameters, these are parameters will be important parameters in your link budget calculation. Transmit power of an antenna, and then again compared to isotropic radiator, EARP, free space path loss, system noise temperature, figure of minute, this is G by T ratio, carrier to thermal noise ratio, C by T, static noise density ratio, and carrier to noise ratio. Remember, at the final stage, we'll be calculating all the carrier to noise spectral density ratio or carrier to noise ratio. Whatever you go for power calculation, the carrier to noise ratio plays a key role in, because that gives us a clear picture about how much losses or how much actual power is being received at the receiving end. So this is an antenna gain concept. The gain of antenna is here. I'll just skip these things and go to the formula directly. That is your final received power directly. So EARP, as I said earlier, the losses have been having a free space loss. So the link budget calculations, the losses will be calculating is your free space loss, receiver feeder loss, uh, antenna misalignment loss, hello, antenna misalignment loss, atmospheric absorption loss, polarization mismatch loss. So the major source of loss is been in the ground satellite link in the free space spreading loss. So for free space loss, we need to calculate all the things that has been happening over here. Received power. This is a transmission formula. ERP is equal to PT into GT. So transmission power, antenna pointing loss, free space loss, and the receiving antenna gain reception loss, cables in the connector. So this is when transmitted here, PR, which is equal to ERP minus the transmission power, antenna, polarization, radiation, other plus GR minus LR. This form equation is easily handled by the spreadsheet. Distance operation we can easily done. It's called as your link budget. The calculation of a received signal based upon a transmitted power and losses and gains involved until the receiver is formed. So link or budget equation. So for transmission, we need to add your power minus your transmission losses and add your minus antenna gain. You need to minus your antenna pointing loss, free space loss, atmospheric loss, receiver pointing loss. And then for reception, the same antenna gain should be added, noise temperature contribution should be added, and minus your reception cables and your connectors. So this is how I'll just share the PPT with ma'am. You can get the information from her. So this is a simple budget power equation. So why should I go for link budget calculation? You should have the system performance type the operation threshold that will be having operation threshold minimum to the minimum power that should be received from the demodulator in order to communications to the whether it is working properly or not. Its operation thresholds depends upon the modulation scheme which being used, desired communication quality, coding gain, additional overheads, channel bandwidth, thermal noise power. So some person will then ask the questions regarding the modulation scheme. So in today's modulation scheme, we are using your ASK and PSK. That is a digital modulation scheme. That is amplitude shift keying and phase shift keying systems in marine and your crop monitoring. Hope you studied up. Hope you got the answer. We are using your ASK and PSK, and predominantly using your 16 QAM for your security-based purposes. So closing the link, we need to calculate the link budget not to verify the closing the link. That is, receive power should be greater than or equal to C minimum. C minimum is a threshold point. Remember, operation threshold. And a receive power link is not closed means PR is receive power less than your minimum level. So link margin will be applied with the receive power minus minimum threshold point. Equally, when margin is greater than 0, the link is being closed properly. Link closing means I'm sending an information, a satellite is processing and receiving towards another range. The margin has been made the link is margin less than 0, it is been not closed. This is an important understanding purposes. So carry to noise ratio. So this allows a simple calculation of the margin receiver bandwidth is known. Required CBN is known for the design desired signal type. So allows a simple calculation to allowable receiver bandwidth if required CBN is known for the receiver signal desired signal type. There are some calculations been happening over here. So G by T. The G by T is called as a figure of merit. That is system figure of merit. That describes the sensitivity of your antenna. That is the sensitivity of your receiving antenna system. So the G by T degrades the most systems when drain losses increases. This is caused by increase in sky noise component and loss of received power supply density. System noise power. The performance of the system determined by your C by N ratio. The most systems require C by N ratio should be greater than 10. Then remember it is in dB. Hence, C should be greater than noise plus 10 dB. So the noise we will be mentioning here is about of your noise power. Remember, it's not calculating the noise. We're calculating. Remember, we always calculating only the power value here in the link calculation. So the noise power plays a major role in it. So the TM is in Kelvin. We can convert the Kelvin in Fahrenheit in every according to our need. A system noise is caused by your thermal noise sources. The external receiving system is your transmitted noise on a link, a seen noise absorbed by the antenna, internal receiving noise. The power available from the thermal noise is your N, which is equal to K into BTS. B is your bandwidth, effective bandwidth system, and T is your system noise temperature. Now, we'll be moving towards your next topic. The TDMA, that's the last topic. Isn't it? So next is here, when broadband communication, what are the frequency range used for the different types of applications? For telephone, we are using 8 to 8000 hertz. So for speech, we're using 300 to 3000 hertz. For video, using 5 to 7 megahertz. That is 64 kilobits for 10 s of Mbps. For TV, we're using the compressed speed of 18 megabits, uncompressed speed hundreds of few gigabits. The high-speed data internet web services. ATM is a asynchronous transfer more things, and IP using 150 Mbps. High frequency band K1 using 20 to 30 gigahertz. So next is an important parameters of multiplexing. So the multiplexing is a concept where I can able to communicate with a different more number of users at the same time. How I'm going to add those things? So the goal here is to have the multiple user shared medium. So the multiplexing channels in the we'll be looking into the 4 dimensions. First is your space, time, frequency, and code. That's what we'll be calling as FDMA, TDMA, CDMA, and SDMA. So the multiplexing is a concept of breaking your higher speed circuit into a several slower circuits. So the main advantage of multiplexing is your cost effective and cheap, because very few need inductive circuit is been working. So the 4 categories are FDMA, TDMA, frequency division multiplexing, time division multiplexing, code division multiple access. This is multiplexing is different from multiple access. These are the basic concepts of frequency division multiplexing. Here you have a host computer that has been giving you the hertz bandwidth, and you based upon the God band, 3000 hertz available bandwidth is been divided from 0 to 3000 level, and in between I'm having a God band of 5 to 10 depends upon the need, and then finally be given to the receiver side. This is a frequency, that is I am dividing the frequency and providing the computer with each set of frequencies. So I'm dividing it to 400, 0, 800, 1. 1000 for 1000, 0, 1001. 0, 1 is meant 0 is meant for transmission, 1 is meant for reception. For sending, for transmitting, for receiving, I'm using 1000. For sending, I'm using 1400, 1400 hertz. This is a simple concept of frequency division multiplexing. The time division multiplexing, it allows the multiple channels used by allowing the channel to send data in particular time. So, it dividing the circuit vertically in using your time. So instead of sending the whole frequency, I'm sending the particular. I'm using the particular frequency at a single time. So that's concept here. Here only the new concept is called as your frequency reuse. The frequency reuse concept is being enabled in your time division multiplexing concept. Instead of providing you the full frequency to the terminals, I'm providing them time to access. That's what I said here. It allows the multiple channels to be used in the allowing the channels to send data by taking turns. TDM is sometimes referred as dividing the circuit vertically. So an example of 4 terminals sharing a circuit with each terminal sending one character at a time. With TDM, the time of the circuit is shared equally. Remember, the time on the circuit is shared equally, with each channel getting a specified time slot, whether or not it has been any data to send. It has been more efficient when comparing with the frequency, because in frequency, if the next user is been coming, he has to wait. Here, using a TDM doesn't have any God band, the entire capacity divided upon the data channels you can able to accommodate more places. Next, so the multiple access issues. So the multiple access techniques, they are using military and commercial use of spread spectrum concept. There are 2 types of spread spectrum concept: direct sequence, frequency hopping, and CDMA systems. So the multiple access and multiple access, the FDMA, TDMA, the concept of random access, Aloha and CSMA. We have studied in communication networks. Same concept we're using here. They use what we studied over there that has been using in your satellite communications. So the capacity allocation strategies is your FDMA, TDMA, and CDMA. So the FDMA, the whole spectrum is divided into small frequency bands. There no dynamic coordination is necessary. Automatically working is particularly working for your light traffic, and between the frequency band is totally, the disordered frequency band is totally wasted at a particular time, and there is no new user can be accommodated in your frequency division multiple access. This is your typical satellite transponder frequency plan for downlink channels. So, for example, I'm having a 500 megahertz bandwidth, that is 3700 to 4200. So, for each 20 I'm using for your horizontal polarization, 2740 I'm using vertical polarization, so that there is no, it doesn't need of a interference between your frequencies. Interference between your frequencies. So this is a vertical polarization that has been happening here. 3720, 3760. Likewise, I'm giving a 3720 up 4 here. 4. Likewise, and keep on moving your based upon the polarization. I'm using your frequency plan, using your frequency division multiplexing axis. So the factors which limit the number of subchannels provided with the satellite channel is your FDMA, thermal noise, intermodulation noise, and your crosstalk. The forms of PDMA. So the FDMA can be done with your fixed assignment multiple axis and demand assignment multiple axis. So assignment capacity is distributed. The assignment capacity is being distributed on a fixed manner among a multiple station. The demands may get fluctuated. This is a significant underuse of your capacity. Demand assignment means, for example, if I'm having any games or any events going there, for the particular reason only, based upon the demand, I'm providing the frequency to the particular area using your satellite. So these are the logical links between the stations are being pre-assigned. The multiple station access the satellite using your different frequency bands. It uses your considerable bandwidth. In demand, there will be sub channel. There are two types of things available: single channel per carrier and demand assigned multiple access technique. So in demand assigned FDMA, and single channel per access will be having only the single channel per each and every carrier. Whereas demand access behind subchannel will be treated as a will be having a set of links that have been available based upon the need. Will be giving you the full duplex communication between your test station. Next, in time division multiple access, we not providing you the frequency instead and giving you the time. I'm dividing into frequency slot based upon the keep on changing. If there's a time slot has been over, the next it will be moving to the next frequency slot. It is allotted to the particular user if it is using. If it is not using, it will get back to its original bandwidth. So the cost of digital component continues to drop. The advantage of digital component use of error correction, the increased efficiency of TDM, and lack of intermodulation noise. These are things we're going for the TDMA technique. This is the things that have been happening in your TDM. So instead of for sending a single frame, I'll be dividing into different station. So for station 1 is being sent, will be sending the station 2. So you'll be having the starting will be having reference bus and ending there in the reference bus. That gives information that the frame period is started and the frame period is being ended. So in between the stations, you'll be having a God time. The particular once it is being sent, the next station will be keep on working. So the station will be consisting of your preamble and your information. So the preamble will be having you the carrier bit timing recovery. Will be having unique word, station identification, network control, and the request. Information will have the data that will be sent between your satellite communication. So the fixed assignment multiple access is assignment of capacity within the overall satellite channel is distributed in a fixed manner among the multiple stations. The transmission is a form of a repetitive sequence of your frames and has been divided into separate time slot and has been given to each time slot has been given to a particular transmitter. A station takes turns using your uplink channel since data in assigned time slot. So the satellite repeats incoming transmission broadcast to all stations. The transmission is a form of repetitive sequence of the frames. The station takes turns using the uplink channel since data in the assigned time slot. The satellite repeats incoming transmission broadcast to all stations. The station must know which slot to use for the transmission and which to use for your reception. Next, this is your frequency assigned multiple access and TDMA concept. So for station 1, station 2, and station 3, we'll be having an interbus God time between your station. Transmission bus slot and bus on slot. The station only sending to session 2 and 3. So the satellite will be transmitting and then sending back to session 2 and session 3. This is your uplink process. And this is your downlink, FAMA, TDMA downlink. So for station 1, it is been sending 1 and 10 and 3, transmission from station 1 and transmission from the station 3 and transmission from the station 2, transmission from the station 1. So for 2 and 3 transmit, this is how happening in your TDMA. There is a time slot based transmission. So to To overcome this, they will be combining the two things, time and frequency division multiplexing. That is TDMA using FDM, TDMA using TDM, time division multiplexing, and so that gives you the protection against frequency selective interference, protection against tapping, adaptive. So and the main drawback, or you can call them as a challenge, is your precise coordination required, because without very precise thing we cannot able to connect between your time and frequency division multiplexing process. Examples to GSM. Next, code. So the important thing is here I'm not going to give them a frequency. I'm not going to give them a time slot. Instead, I'm going to give them a codes for each and every user, for each and every user, for each and every plan. Hello. You can able to give them a code for everything. So the all channels use the same spectrum at the same time. So the advantages is your bandwidth efficient. There's no coordination and synchronization between hard to tap, almost impossible to jam. So the problem is if they don't use the data rates, it becomes waste, and more complex signal regeneration will happen. Example is your UMTS. Remember, you can able to easily understand your FTMA, TDMA, and CDMA using your mobile communication process. Your first generation mobile communication is your FDMA. Your second generation is your TDMA. Your third generation is your CDMA. Your fourth generation is your OFDM. Your fifth generation is your MIMO concept. OFDM next is your MIMO concept. That's the green technology. Code division multiplexing. It is used in several wireless LLM, all standard using your code. A unique code is assigned to each user. That is a code set partitioning. So the all users share the same frequency, but each user is having their own chipping sequences. Encoder signal is your original data into chipping sequences. Decoding is your inner product of encoding signals. Allow the multiple users to coexist and transmit simultaneously with minimum interference. If the codes are orthogonal. Just complete. I just complete with this. Just 2 minutes. So, so we have seen about some satellite and how the things has been happening here. So if you look at the exam-oriented point, we need to approach is totally different. The first unit is about of satellite orbits. We're talking about totally different about orbits. The second is about of subsystems. We'll be predominantly concentrating on subsystems. Predominantly, we'll be having your anti orbit from the important topic. And third, you will be having link design, carry to noise ratio link design, C by N ratio for calculating uplink and downlink. In that, will be including your noise parameters also. In the fourth unit, we'll be discussing about the access technique. There will be having three access techniques: FDMA, TDMA, and CDMA. In the fifth unit, we'll be having mostly application-oriented questions. Particularly, if you look at the GPS, GSM, VSAT, everything will be available over there. So the satellite missions we're using for in this 66% of satellites is used for your communication purposes only. For Earth and science meteorology using 5%, astrophysics and space is using 5% of the satellite, Earth observation remote sensing using 5% of that is in total available satellites. The military surveillance satellite is using 6% and 7% used for the navigation purposes. So we know that the government of India has launched a satellite called INRSS. So that is particularly meant for it is a global navigation system like GPS. The government of India has been deployed. We have already launched using two rockets. We have launched. We have one more rocket. If it is launched, we'll be having our own global positioning systems in the market. Similarly, the satellite orbits that have been present here is the total more number of orbits have been happening in the LEO, because more number of communication purposes have been happening in your LEO level. That is your internet, TV, everything happening in your LEO level. GEO using for 43%, MEO 6%, Molania is 2%, and the polar orbits comes in here 3%. I'll answer some questions. First question is here, can microwave used to communicate with satellites? Yeah, we can use it. Based upon the antenna we have been designing, we can use the satellites, which depends upon the frequency of design. Microwave, which microwave frequency you're using, you can communicate with the satellites also. What is done after the satellite takes place? So likewise, in space, you have graveyards. So the satellite, once operational time is being expired, the satellite will be automatically moved towards the graveyards. We have about of nearly you're reaching a nearly we're reaching in crore lakhs of satellites that has been present in a graveyard. So the ITU and all other countries have been defined to send some space launch to destroy all the satellites into a tiny particle, so that it will be revolving around the space and does not come to the Earth. Or they will be trying to push the satellite towards another, and they will burst the satellite when it comes into the gravitational force of the Earth. You have graveyards for those satellites.
Excuse me, sir.
In today's modulation technique, you're using your ASK, PSK, and for security purposes, they're using your 16 QAM and 32 QAM in your satellite communication, marine, and your crop point. Yeah.
Sir?
Yeah, ma'am. Yeah, PPT is over, ma'am.
Okay, sir. We'll go with the question answer session, sir. So people will read out the question answer.
Yeah.
Yeah.
So.
Thank you, sir, for your wonderful session. It was informative and interesting, especially when you told us about how the satellite was developed and launched. It was very useful, sir. Thank you so much, sir. Now, let's have question and answer session. Ms. Vinita will take over the session. Over to you, Ms. Vinita.
Thank you, Jolene. Thank you, sir, for sharing your knowledge with us. There are multiple questions in the chat box. Due to our time limit, we have selected some interesting questions. The questions are, how this military satellite are secured from another country armies? Sir?
Can you repeat the question again?
How this military satellite are secured from another country armies?
How this military
satellite are secured from another country armies?
So the military satellites, if you look at the military is always an closed organization. They'll be having all the information to track what the enemy or satellite has been moving here. They'll be having the monitoring satellites that have been that is called as spying satellites that have been available in our space. So based upon the frequency of operation, what frequency of operation they will trying to decode what the signal has been transmitted between your opposite parties, what the communication has been held with help of your satellites. Next question.
Next, what is done after the satellite expires from its operational life? Sir.
Yeah, the satellite will be moving towards your graveyard position. They'll be having a satellite, they'll be having a space graveyard. The satellite will be moving to graveyard position, which is also an latitude longitudinal position. It will be moving towards your graveyard.
The next question is, what modulation technique is used in today's satellite communication systems in marine and for crop monitoring?
So we are using your ASK and PSK digital modulation technique in today's satellite communication. And for marine and crop monitoring, we are using your 16 QAM and 32 QAM, that is quadrature amplitude modulation.
The next question, how close can two satellites be placed in the orbit since there are more than 2,000 satellites?
2,000, you're saying in a very little lighter way. We have about of 20 to 30 lakh of very tiny satellites that have been available over there. We can space. That's called as a constellation of satellites. Based upon the application, you can keep it in a lighter mode, such a way that it is not getting crashed over there, and there is no any interference between the satellites.
Could you tell us how the eclipse affect the satellites, sir?
Hello?
Could you tell us? Hello, sir?
Can you repeat the question?
Could you tell how the eclipse affects the satellites, sir?
Which question? Can you repeat again? Sorry, there's a break in your voice.
Okay, sir. Could you tell how the eclipse affects the satellites, sir?
Oh, eclipse. So when you're looking at the eclipse, so we know that we have two types of eclipse available in every year: lunar eclipse and solar eclipse. During that time, the operation of a satellite is being destroyed. So it first affects the solar panels, that is the energy coming from the sun towards your satellite. So as I said earlier, the satellite signal, the power system is getting affected during the eclipse time. It's a major factor for doing eclipse time. There's no problem with your signal reception and every other thing. The major disruption during eclipse time is your power management. It has been done with it has been resolved using your batteries that is in present in the satellite. They will switched on when during the eclipse time.
Thank you, sir. Give us view on geosynchronous satellite. Hello.
Yeah, thank you.
Give us a view on geosynchronous satellites, sir.
Hello. Voice is too break.
Sir, hello.
Yeah, you can hear me.
Can you hear me, sir? Hello. Can you hear me, sir?
Yeah, you can hear me.
The next question is, give us a view on geosynchronous satellites, sir.
Geosynchronous orbit, right?
Satellites.
So we know that can you hear me?
Yes, sir. Yes, sir.
Can you hear me?
Yes, sir. We can hear you, sir.
So the geosynchronous orbits is also kind of a prograde orbit. Prograde orbit is the satellite is revolving around the east-west direction. That is the rotation of your Earth. It's a prograde orbit which having the low inclination orbit. So the spacecraft appears to remain in the above the Earth at a constant longitude, and it will wander in the north and south. That's called also geosynchronous orbit. It's a low inclination orbit having the same period of your Earth's rotation.
Thank you, sir, for your answer. Thank you so much, sir, for answering all our questions patiently. All your answers are more valuable and knowledgeable, sir. Still, we have some more questions to be answered, but we are running out of time. We will be mailing all your questions, sir. Students, please don't worry. All your questions will be answered. Thank you. Over to you, Jolene.
Thank you, Ms. Vinita. Premise of the magical words is thanks. Token of gratitude is always to be remembered. And so here we have Mr. Abhishek to sign off the token of gratitude. Over to you, Mr. Abhishek.
Thank you, Ms. Sterling. Good evening, everyone. Respected and most distinguished chief guest, respected principal, our beloved HOD, our honorable professors, and my dear friends. I deem it a great honor and privilege to propose hearty vote of thanks to those who have directly and indirectly contributed to this webinar on satellite communication insights organized by our department. Let me first of all give glory to the Almighty God for making today's webinar a resounding success. I would like to thank our chief guest and resource person, Mr. D. Gururaj. We are really enlightened with your knowledge and presence. Thank you, sir, for your very interesting and thought-provoking address. We are very glad to have learned some new knowledgeable things about satellite from you. Especially the question and answer session was very informative and knowledgeable to our students. I would like to thank our respected principal, Dr. Sujata Anand ma'am, for supporting us. I would like to express my sincere gratitude to our beloved Vice Principal and HOD, Dr. Nalini Joseph ma'am, for her words of encouragement, her support and guidance, and also for giving us the opportunity to bring out our talents. My heartfelt thanks to all our faculty members, program coordinators, and student coordinators for their involvement and the willingness. I extend my special thanks to our HOD, Dr. Nalini Joseph ma'am, for her effort in bringing our resource person for the webinar. I heartily thank all the participants for their active participation in this event. No program can become successful with a single person, so I extend my big thanks to our department, and I thank all the participants who showed up their interest for the webinar with utmost curiosity. Once again, I thank everyone who gathered here and made this event a successful one. Thank you for the opportunity. Over to Mr. Erling.